Bismillahirrahmanirrahim. Assalamu alaikum dear students. I welcome you all to the next session of the Linux lecture series. And before you proceed with this lecture, I strongly recommend that you should go through the video regarding the standard file permissions. And let me start with the special permissions. Today we are going to talk about the special permissions in Unix. We all have seen that the Unix keep 3 bits for managing the permission for others, 3 bits for the group, and 3 bits for the owner. And we have also seen it keeps 4 bits to manage the type of the file. Over here we have 3 bits, the SUID, the SGID, and the sticky bit. And today we are going to talk about these bits, and they are known as the special permission bits. Before we start with the SUID bits, let's play a game. Let's suppose that we have a user named user1 who is having a directory and is having a lot of files in it. Right now, remember, I am root. Let me get inside the user1 home directory and let me create a file over there with the name of game. Let it be a script, #bang bin bash echo do you want to play a game with me? And note this line, and that is it. And let's make it executable by chmod, executable by others. Now if you see that this is a fine executable game. Okay, let's suppose that user1 logs in, sees the contents of his home directory, and find out a pretty fine program named game over here. He presses ./game and it starts by saying that, do you want to play a game with me? Now if you know the contents of this script, you know if I press enter, a lot of bad things will happen. Remember gentlemen, if you press enter, not the entire system files will be deleted, as you can see from here, but only those files which are owned by user1 will be deleted. The RM will traverse all the directories and will delete all those files who are owned by user1. Okay, let me do Control-C and come out. Here comes the role of the SUID bit. Let me show you the game program again. It is having these permissions over here. Let me set the SUID bit of this file by saying chmod U plus S game. The SUID bit of a program is represented by NS over here. It is represented by a capital S in case the owner do not have the execute permission, and the lower S if the owner has the execute permission. Now what actually happen is, now this program whenever run will run by the power of the owner of this program. Now here we have the user one logged in. If the user one starts this game now and he presses enter, this game will run with the power of root, because over here you have seen that the SUID bit of this program is set. So remember gentlemen, SUID bit is set for the executable programs, and any program which has the SUID bit set will always run with the power of the owner of that program. So I personally strongly recommend you that you must never set the SUID bit of a program. If it is so harmful, then the question arises that why the operating system kernel has given this facility of SUID bit. Okay, I am root and I am in the home directory. Let me give a command to find out that what all files in this system are having their SUID bit set. Find from root with the parameter of permission, and the permissions are for 000, and I'm not interested in any error messages. You can see this program is having its SUID bit set, and the find program is finding out other programs as well. Let's see what all programs are there having their SUID bit set, about which we know a little bit. We know a bit about the SU program, which is used to switch user. And there are other programs like, for example, the passwd program. We'll soon see over here that passwd is a program which is having its SUID bit set. Let me close this. It is making it a bit slow. Yes, you see here is the USR bin passwd program which is having its SUID bit set. Here is USR bin chfn program which is having its SUID bit set, and the sudo program, and there are many programs which we know about. So let's see what are the permission on USR bin passwd. If you see this program, it is having its SUID bit set because it is having S in the execute part of the owner's permission. Now what this program actually do is, you use this program to change the password, and the password is kept in a file that is shadow file, and shadow is a file on which a regular user do not have any permission. So how is it possible that a regular user, for example Kakamanna or Arif or someone else, can use this program and write this file? This is because of the SUID bit. So I strongly recommend that let the operating system handle SUID bit on executables, and in person you must not set the SUID bit of executable programs because it may be very harmful for the systems on which they execute. Now the question may arise that does this mean that anybody can change anybody's password? Let's try that. I'm user 1 right now. If I write PASSWD, my own password will be changed. And if I say passwd Kakamanna, basically I'm trying to change the password of Kakamanna. And it says you may not view or modify the password information for Kakamanna. So although the SUID bit of this program is set, but using this program, a regular user can only change their own password. Right, gentlemen, as far as the SUID bit is concerned, it is normally used only for the executable files, and it has no meanings on a directory. The second special permission bit is the SGID bit, the SGID, group ID, set group ID bit. Like the SUID bit, SGID bit is also normally set for the executable files, and it works the same way as the SUID bit, but it uses the effective group ID and not the effective user ID. Let's try to understand this. Remember, I am root right now, and let me check out the files having their set group ID bit set, and I will use the same command find, and I will say find all those which are having the permissions 2 in their special part, and I'm not interested in any error messages over here. So once you run this program, it will show you a lot of files, and the files of our interest are, let me scroll up a bit. Okay, there are a lot of files, and I can see directories as well over here. Right now, which is that executable file which I can discuss with you, which is easier for me to make you understand. Okay, sbin local share. Okay, there are a lot of files and directories which are having this set. So there is a file that is somewhere in, that is the chage file. Let me check out with the chage file. Let me close this. You can ls-usr/bin/chage. Okay, so you see this file. This is also an executable file which is having an S in the execute part of the group permission. So these are the group permissions, and it is having an S over here. So that means it is having its SGID bit set. So SGID bit is represented by an S in the execute portion of the group permission. It is a lower S if there are execute permission for the group, and it will be a capital S in case if the group execute permissions are off. And the same thing we have seen in case of SUID bit as well. And can anybody tell me what chage is used for? Yes, you are right. Chage, user password expiry information. We normally use chage to check out the expiry information. Let me be a normal user. I'm user 1, and I'm using chage to check out my password expiration information. So you can see that this information is here, and this information is read by chage program from some file. And we know that file is, yes, that file is again at SGID. And once again, for user 1, at SGID is non-readable. It is not readable. So when a regular user executes the program chage, the chage program runs with the power of the group, which is shadow, and this program reads the @c shadow file, which is also having the group shadow. So it executes with the power of the group, and the group has read permissions on it. So let me rephrase that when a regular user executes the program chage having its SGID bit set, it runs as it is being run by a member of the shadow group. Therefore, this regular user is able to read the @c shadow file. So now, after having understood the use of SGID bit on executable files, let us now try to understand the use of SGID bit on directories as well. We have seen that SUID bit has no meanings on directories, but SGID bits of course have meanings on directories. And that is of course very interesting. Let me clear the screen. And in order to understand the usage of SGID bit on directories, let me first create a shared group environment. Okay, what is a shared group environment? A shared group environment is in which there are multiple users belonging to different groups and they work together on files on which they have common permissions. So let me first create two groups, a group named faculty and students. And we know the command to create a group, it is add group. We have created a group faculty and we have created a group students. Remember gentlemen, this portion we have done in the user management part. If you are not comfortable with this, please go through with that lecture. Now let me create 4 users with the add user command. A user Mansoor with the password of course, with the default setting. And let me create another user Farhan, let's suppose. Let me give him a password with everything default. Let me create another user Maz. And let me create another user Hadid. Now I've created 2 groups, faculty and students. I have created 4 users. Let me check that Mansoor belongs to a group that is Mansoor, and Farhan also belongs to its own private group Farhan. Let me add Mansoor and Farhan in the faculty group by the command user mod -a for append and capital G for the secondary group. Faculty is the group. And let me add Farhan as well. Now if I check Farhan or Mansoor, you can see that they are member of their own private group as well as the secondary group is faculty now. Let me add the other 2 users in the students group, Maz and Hadid, by using the user mode command. You can check out now, Maz and Hadid are 2 users which belong to student group, and Mansoor and Farhan are 2 users who belong to faculty group. Now let us create a directory hierarchy in which these 4 users are going to work together. Let it be in data, Let me use -p over here so that the parent directories as well are created if needed. So this will create a directory fdata in data, and let me create ns data in data. So okay, so now we have two directories. Let me see the long listing of these two directories inside it. So these are the two directories which we have created, a directory fdata and a directory sdata. Now let us change the group of these directories from root. Since the root is right now creating these directories, let us change the ownership of these two directories from root to faculty and student respectively. Let me use the chown command of faculty, the data f. Let the f data be of faculty and the s data be students group. Let me do ls-l to data. So you can see now the f data directory belongs to faculty group and s data belongs to student group. Now any user who belongs to the student group will have these permissions. That is, the students will be able to read, write and execute files in sdata, and faculty will be, of course, be able to read, write and execute all the files in fdata, and the faculty will have these permissions in the students folder, and the students will have these permissions in this folder. Let's suppose this is our requirement. Okay, now let us confirm this by logging in over here. Let me, this is user 1. Okay, let me exit from user 1. Let me say, who am I? I'm Arif. Let me exit to Hadid. Remember, since I have used a hyphen over here, you can see I have changed the directory. Before I was in the home directory of Arif, and now I'm in the home directory of Hadid, the currently logged in user. Now I'm Hadid, and my directory is of course empty. Let me create a file over here. Learning Linux is fun with Arif. And let me redirect to it a file f1. Let's suppose I can cat f1. So this is a file which Hadid has created over here. Now let us log in onto another terminal as, let's suppose, Mars. And let me move on to data, s data, and let me check out. It's empty. File should have been here. Oops, I am stupid. I needed to create this file in this directory instead. Remember, I am Hadid and I wanted to create a file over here. And let me switch to Mars now. And now I can see the file f1 over here. Let us suppose that Mars wanted to add something in this file because they are working together, and Mars says, I disagree. Permission denied. Why? Okay. So Mars is trying to write this file f1, which is owned by Hadid and the group is Hadid. So Mars is others for this file. So Mars cannot write this file. So that is the reason that we have got the permission denied message. So here comes the SGID bit on directories. Let me be root now. And let me add the SGID bit on this. And before adding SGID bit, let me see the long listing if the read permissions, write permissions are required. They're not required. Okay, so let me say chmod and I say G plus W. Do I have to do that? Or I have to set the SGID bit. If I have to set the SGID bit, do I have to do something like this on data, on everything inside data? No, this will not work. I don't think so. / data. No, to set the SGID bit, I have to do something like this, G plus S. If I do now, ls-l data, yes. Now you can see the SGID bit of the F data as well as the SGID bit of S data is set. Now let's try again. Hadid. Okay, here I am Hadid, and Hadid created a file. Learning Linux is fun with Arif, but let it be now file F2. Now try to understand. Hadid used this command a while ago and created this file. Note the owner of the file is Hadid and the group of the file is also Hadid. Now Hadid used the same command again and created a file F2. Note the owner of the file is Hadid and the group of the file is student. Since we have set the SGID bit on this directory, so any file or directory that is created in it by any user will have its group set to the owner of this group owner of this directory. And this happens so that different users can jointly work together. So now let's move on to Mars and let Mars repeat the same command on file F2 and press enter. You see it is a success now. It was given an error before and it is a success now. If I do ls-l, this time Mars is successful in writing on file F2. Although, if you consider Mars as others, you do not have write permissions on this. But this time, this student's permission, this group permissions are being applied. Remember, gentlemen, whenever permissions are applied, they are applied first, they are checked whether the program is having the effective user ID of the owner of the file. If not, the program is having the effective user ID of the group of the file. If not, the program is having the effective user ID of others. So in case over here, since Mars is member of students group and the members of students group have read-write permissions on F2 file, therefore Mars is successful in doing it. So gentlemen, I hope that I have made you understood that the use of SGID bit is very important as far as the shared group environments are concerned. So let me repeat again for your memorization that if a directory has its SGID bit set, that any file created in it will automatically inherit the group memberships of that directory. And if the S data has the group membership of students, then all the files which are created in S data will have the group membership of the students. Right, gentlemen, let's move on to the last part, and that is the sticky bit. Till now we have seen the use of SUID bit on executable files, and SUID bit has no meanings on directories we have seen. And we have also seen the use of SGID bit on executable and the very interesting use of SGID bit on directories used in the shared environment. Let's talk about the SGID bit. Let's continue with this shared group environment, the same scenario, and try to understand the use of sticky bit. Let's suppose that over here I am Hadid, and if I do ls-l, there are two files on which these are the permissions, and F1 and F2 both are managed by Hadid. They are owned by Hadid. Let me come up over here. I'm Mars right now. Can I delete this file F1 or F2 by using a command, let's suppose rm? You see, Mars has successfully removed a file F1 which is owned by Hadid, and its group is also Hadid, while Mars do not have write permissions even on this file F1. So gentlemen, please clarify this doubt that to delete a file, it is a directory operation. It is not a file operation. Since Mars has write permission on the S data directory, therefore Mars has been successful in deleting this file, although Mars do not have write permission on this file. So this is not good. That is a very bad thing. In a shared environment, group members are of course allowed to read and maybe write each other's files, but they should not be allowed to delete each other's files. Here comes the solution of sticky bit. Let's see how we can set the sticky bit on this directory. Let me be root again. I am root. Let me use chmod command and let me set the sticky bit O plus T. Let me set the sticky bit on all the directories and data. The sticky bit is represented by a T in the execute portion of others permission. You can see a T over here as well and a T for S data directory as well. You normally see a small t in case if the others have execute permission, and if the others do not have execute permission, you may see a capital T over here as well. Now let us come back over here. Now F2 is a file that is owned by Hadid. I am Hadid over here. Let me be Mars. I'm Mars over here. Let me clear screen. And this file F2, which Mars deleted before as well, which was actually file F1. Now if we consider the same scenario, Mars should be able to delete this file as well. But now you see operation not permitted. It is because the sticky bit of this directory is set. So let me say that by setting the sticky bit of a shared directory, only owner of the file Hadid can delete the file. only owner of the file Hadid can delete the file, or the owner of the directory may also delete the file, and owner of SData directory is root, so root of course can delete all the files within this directory, and that is very much required. Suppose this hierarchy has been created by the manager of a department, or maybe by the principal of a college. He of course have all the rights to delete anyone's file, but of course within this SData directory, no one student should be allowed to delete anyone else's file. So that is the requirement of the sticky bit on directories. Let us find out using the find command again, perm 1000 for this, and let me redirect of course to null, the output which I am not interested in. Let's see what all directories have their sticky bit on by default in our system. And there are a lot of directories, and one of the directory is, gentlemen, the /temp directory. And you can see this fdata and sdata, of course. These are the two directories on which I have myself set the sticky bit. And if you see up or down, maybe you can find the directory temp as well, on which the sticky bit will be set. Let me Control C and let me do ls-ld temp. So this is the directory on which you have the sticky bit on. So there are a lot of directories in the system which have their sticky bit on. So gentlemen, one last thing, sticky bit on files. On older Unix implementations, gentlemen, sticky bit was provided as a way of making commonly used programs run faster. The underlying concept was that loading a program from disk is slow as compared to loading a program from swap space on disk, where the program is normally not fragmented. So in older Unixes, the sticky bit of an executable was set. If the sticky bit was set for that executable, the first time it was executed normally, later on a copy of that program is saved in the swap area. That is, the executable program sticks on the swap space, and next time when you execute that program, it loads faster. But today, in the today era, the modern operating systems do not use sticky bit on files, because the current sophisticated memory management schemes have rendered this use of sticky bit obsolete. So that is all, gentlemen. It was tiring for me, of course, but I hope it was informative for you all. Allah Hafiz and happy learning.